Hi everybody, Dr. Pingle here. We're going to go through how to download Lidar from the national map. So this is the national map download section. If you look over here on the left, you'll see a lot of things that you're probably familiar with. Imagery, boundaries, structures, things like that. One of the things that you might be interested in is Lidar. So there are two categories for elevation data. One is elevation products and one is elevation source data. Elevation products are going to be what we've been used to seeing so far, DEMs and the like. But elevation source data is where you would go to download Lidar point clouds, which is the kind of native format for Lidar. These are distributed via the national map in these two formats, so LAS and LAZ. LAS is the standard format. LAZ is a smaller compressed version of that. It's not zipped, but it's sort of, because of the zipping is kind of synonymous with compression, they use the Z to indicate that it's compressed. You can show all availability across the United States, so you can see that the pattern of Lidar varies quite a bit. So in this kind of arc through the Midwest out to Pennsylvania, there's quite a bit of coverage actually through Iowa, northern Missouri, most of Minnesota, most of Kansas, Indiana, Ohio, Pennsylvania, and Illinois is mostly covered with a couple of odd counties here and there. And in fact, some of these have actually already been included, but haven't been posted to the national map. And that gets at kind of one important issue, which is that the national map, while a very convenient one-stop shop, is not necessarily the de facto, or I should say, it doesn't have the most current up-to-date information. It can take a little bit of while for the data to get up here. Some of the counties have scanned data, but not necessarily posted it to the national map, and so there's quite a bit of variability here. So you'll notice that most of the concentration of Lidar data is kind of on the eastern half of the United States. It's pretty spotty in the western U.S. A lot of the value of Lidar comes from its application to agriculture, so that's why there's quite a bit of imagery captured here. It's very useful for monitoring coastal areas, so you'll see that quite a bit of the coast has been sampled. But it gets used for a wide variety of things, and so you know, the applications of this are pretty close to limitless. But certainly you should notice that most of the western U.S. is not really well covered. If we zoom into Virginia, for instance, you'll see that most of the eastern portion has been covered, but big portions of the western portion are not here. Now, actually, a lot of this has already been scanned. Close out my email here. A lot of this has actually already been scanned, but hasn't been posted, and so in the next lesson we'll talk a little bit about that. But if we just wanted to download a particular area, so we could zoom in here and maybe take a look at Washington, D.C., for instance. So the kind of plan to get this data works the same as with any other data. You can put a location in here. You can look for things by coordinates. In this case, we'll use the current extent, and we'll zoom in a little bit more here on Washington. And we'll just hit find products. So this is going to do a search for any Lidar in this particular area. You can click on these and get a footprint. So this particular area has been scanned. We can kind of tick around here and sort of see what shows up. You can see that these are more or less adjacent to one another. That's not always the case, but if you're lucky if it is. Anyway, we'll download one of these just to get a look at it. If you click on this, you'll get some information about the product itself, and you can get a lot of that metadata from over here on the left too. So a lot of times metadata gets tagged in the file names, which is really handy. In this case, this is USGS LiDAR point cloud data, Maryland, Virginia, from Hurricane Sandy, flown in 2014. And so the published date is 2015. But if we go to look at it inside, there's a potentially a good chance that this was actually flown in 2014. We'd have to look to be sure. So if we click on this, or if we hit download, both of that's going to take us to the same place. So we'll just hit download here. And this is going to provide you with a zipped file. So like a lot of other data that's relatively large in size, it's kind of nice to be able to compress that. So in the LiDAR formats that we talked about, LAS is sort of the standard. LAZ is a different version of that. But another way that people distribute LiDAR data is to just literally take an LAS file and zip it. So they compress it using sort of standard tools. And that's a perfectly reasonable way to shrink the file size down as well. I'm going to pause the video while this tiles in. Looks like it's got about another minute left. Okay, so that data has finished downloading. We can show it in the folder and then unzip it to get a look at it. So here we're seeing the unzipped LAS file, which got dropped in here. Now I have a version of Cloud Compare open already, so I'm just going to close that and then open Cloud Compare. Now Cloud Compare and Cloud Compare Stereo are actually two sides of the same coin. Cloud Compare Stereo lets you do some interesting 3D views. I found it's slightly less stable than the regular version, so unless you're doing that, I probably wouldn't recommend it. We've got things in here like the data dictionary and metadata. At some point we'll take a look at that stuff. But if we want to just take a quick look at it, we can grab the LAS file. So we'll move this over here. So this is the USGS LAS file. You can see that the size is about 218 megs. If we bring that in to Cloud Compare, we'll get our sort of usual prompt here about what pieces you want to bring in. So I'm going to uncheck everything except intensity, which is nice because most of these other things aren't super useful for visualization. Anyway, so we'll bring in this for now. Okay, so this is a section of DC, kind of by the there's some bridges that you can see, bits of the Potomac. It's a little bit hard to see, and that's partly because this intensity value doesn't always really scale very well. We can improve the contrast by dragging this down a little bit so we can really kind of see what's going on. And this creates sort of a slope shading style view of the area. So there's one of the bridges going across and an interchange. Maybe not the most interesting LiDAR tile in the world, but you can certainly see the pieces as you look at it. One of the things that we can do here is just again visualize this by color. So we can go into our edit box, scalar fields, and export the coordinate to a scalar field. Z almost always looks better. And almost always, and let's zoom out here, you're going to find that you're going to have some pieces in here that aren't quite what you would hope for. And this is a very good example. So the bounding box that you see covers all of the points that are in the data set. So what's going on here is we actually have pieces of this data set that don't belong, and this is actually pretty typical. If we zoom in on this a little bit, you can probably get a pretty good idea of what that is. There's a good chance that that's an airplane. As the scanning was happening, an airplane was landing, probably at Reagan National Airport or something, and got captured in the frame. So we might need to get rid of that. So one of the things that you can do is there are tools in here to manipulate this box. I'll show you two of them. So this box is a cross section, and what it lets you do is you can grab these arrows and move it down, and it's basically going to cut out anything that is out of that view. And as you can see, if we move this down far enough, we're really going to cut into our field. But at the very top, what we can do is just use it to get rid of those airplanes by dragging it down. So we could export this as a new cloud. And it's already done that. So over here we've got two different copies. Now it didn't write these out to disks. Unlike ArcGIS, Cloud Compare does most of the stuff in memory. And so if you want to save it, you've actually got to go through the trouble of clicking on the piece that you just made, going up to File, and then hitting Save. in which case you get a bunch of different options for how you want to save this stuff. So you can save things as point cloud library files, shape files, which you may find useful, meshes, all kinds of different things. In this case, we still have both of our things visible. So the reason we still see these planes is that our original LiDAR data set is visible. So if we uncheck that, then the planes go away, and we're left with the tile that we had. Now, if you look at this particular piece, we'll click on it again, we've still got a lot of pieces here that we don't need. So we might have some what are called low outliers. So the planes would be things like high outliers, things that are too high for our view. But we have some low outliers here as well. So we can go in here and change the cross-section view and bring this down a little bit to get rid of some of those. And we could just export that as a new slice or as a new cloud, and we'd get the same thing that we had before. So you see that new cloud show up here. All right. So this is quite a bit of a better view. If we wanted to go into to customize this a little bit further, you can see that still most of our data is down here. As we drag this over, you're going to really get a much better view of the data, and we can similarly do that. So this is a nice way to sort of manipulate the cloud. Now I told you I'd show you one other way of doing that, so I'll do that now, and that is to take the segment tool, and you can carve things out based on what you see. So it says segmentation on, left click to add contour points, right click to close. What I'm doing here, and you can actually do this with an existing polyline. So if you have a shapefile, you can use that. You can set this to a polygon or a rectangle, and we'll talk about these other two pieces here in just a second. So I'm going to leave this as a polygonal section, which means that I can sort of freehand come in here and carve pieces of my point cloud out. All right, I hit right click to close. Again, a 3-button mouse really makes life a lot easier with this software. If you can get a hold of one, that's going to make your life a lot easier. So we've marked this polygon. Now what we want to do is we want to just scoop just those points out. So I'm going to hit this button, which is segment in. So that's going to get rid of anything that's outside of that polygon. And if I hit the checkbox, it's going to essentially separate those two clouds into what was inside the box and what was outside the box. So I get something that looks like this. Okay, so that's a quick introduction to both downloading from the national map and using a couple of the tools to segment pieces in and out. So this was the segment tool and this is the cross-section tool, and both of those are very valuable for moving pieces in and out. One of the things that I'll just show you really quickly is you can actually segment multiple times. If we start drawing a polygon here, we can right-click to close that. We can actually go in back here again and unpause the segmentation and redraw another piece and then segment that in. So you can sort of selectively, iteratively refine pieces in and out, and this is a really handy way of getting rid of multiple errors. So let's show you how that might work. All right, so in this case I have our two planes right here at the top. If I zoom in, all right, so these are two images of the same plane. If I wanted to use the segment tool to remove both of these, for instance, I could hit my button here, and in this case what I want to do is not keep this, I want to remove this, and that's where this button comes in handy. So I'm going to segment that out, all right, making that plane go away. But now I've got the second plane that I want to go away. So I'm going to hit unpause here and right click, and I can make that plane go away as well. Now obviously I could have done that one at a time, but in some cases you're going to want to change angles to move these things around. So you can shift position, you can kind of move in and out, and then you can get rid of things that way. When you're done segmenting, you confirm the segmentation with the check mark. And now again we've divided this into two pieces. One is just our airplanes, which is a pretty cool little representation right here. And the second piece is our point cloud without those in it. All right. Now it may be that there's still a couple of strays out here, so that's why on kind of a larger level I really do prefer using the cross-sectional tool to remove this until I can see that I'm really starting to eat away to my features. You have to be a little bit careful if there are some tall features in there. You don't want to remove them. So the National Cathedral or something is some tall towers sitting on a hill. You don't want to remove that. But that's a pretty good introduction. Hope you followed along with that, with both drawing these things and manipulating the point clouds and carving some things out in Cloud Compare. Thanks for listening. Bye.